With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, I am going to explain this question, and the question is: a small block of mass m moves on a frictionless surface of an inclined plane as shown in the figure. The angle of incline suddenly changes from 60° to 30° at point B. The block is at rest at A. Assume that collision between the block and the incline are totally inelastic. The speed of the block at point B immediately after it strikes the ground incline is. Okay, the question is: the block of mass m, it moves from A to B, then it collides at B with the inclined plane, and the collision is perfectly inelastic. After that, when the speed of the block at point B immediately after it strikes the second block. Okay, what is the velocity of the block after collision with the inclined plane at B? Alright, this is a good question, so let's solve it. Right, let's first find the before collision and after collision. So before collision, right, velocity of block will be mgh, right, root under 2gh. Velocity of block will be root under 2gh, right, and h in this case is, if we the h will be this one, right. So h, we know that h upon root 3 is equal to 1060, right, and when h upon root 3 is equal to 1060, which implies h is equal to root 3 into root 3, which is 3 meter. Right, value of h is 3 meter. So if you put the value, velocity of block will be, let's just call it u, right. Velocity of block, let's just call it u, is equal to 2 into 10 into 3, right. This will be 2gh, right, which the value is approximately 2 root 15, right. This is the velocity before collision, right. Now let's look at the plane and try to understand it. Okay, so this is our plane, right, and this angle is 30°. This angle is 30°. Now velocity of particle is somewhat is high, like it is here, like this is u, right, and if you cross it, you will get this angle is 60, so this is 30, and this angle will be 120, right, this is 60, this will be 120, and we know that, yeah, this is 60. Let's try to understand the diagram first. This is 60 and this is a straight line, so in order to straight line, this should be 120, right. This is the direction and this is vertical, right, and yeah, this angle is, this is 30, and this is, since this is 30, this will also be 30°, right. So let's try to draw the diagram again. Okay, so this is our incline. Okay, let's just try to, like, for better visualization, I am taking this horizontal line as an inclined plane, right. Let's say this is our inclined plane, then a particle is colliding here, right, and this angle is, this angle with the incline is 30°, right. This is our inclined plane, right. Okay, now it's easy to, like, draw the velocity along and perpendicular to the incline. So there will be a component that is perpendicular to the incline, and there will be a component that is along the incline, right? This angle will be 60, right? And this is our direction of velocity. So one of the perpendicular component will be like perpendicular component, right? That will be u cos 60, right? And parallel component will be u sin 60, right? Or root 3 u upon 2. Okay, this will be u upon 2. Now since the collision is elastic, perfectly inelastic, since collision is perfectly inelastic, perpendicular component will vanish, only parallel component will be there, right? So after collision velocity of block will be is equal to u sin 60 or root 3 u upon 2. Now we can put the value and we will get the answer. So what will be the value? Root 3 u upon 2. Value of u is 2 root 15, right? So which is equal to root 3 upon 2 into 2 root 15, which is root 45. Since collision is inelastic, perpendicular component will vanish, right? So our answer will be root 45, which is option B, right? This will be our answer. Okay, our answer will be option B. Alright, this was the explanation. Hope you understood it. Bye bye.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.